Hey guys, this is Jackson, and today in this tutorial we're going to be doing part 2 of our endless Minecraft random world generation algorithm. So if you want to follow along today, make sure that you go and do part 1, because we're going to be building on the things that we built in part 1. So if I just give you a quick overview of what we're going to be doing today, I'm going to show you how to import a noise plugin. We're going to be using that noise plugin to generate 2D terrain, so the terrain is going to have some height for hills and some valleys and other weird structures and things, and I'll show you how to use that noise plugin to get different types of terrain. We're going to add some depth to our terrain. At the moment it's just a single surface, so we're going to add some blocks below the surface, tidy some things up, add some materials so that it looks a bit more interesting than just grass, and then finally we're going to do some 3D noise. So we'll use 2D noise for the surface and 3D noise beneath the surface so we can generate some caves and things like that. If all goes well, we should get through all of that, but I guess we'll just have to wait and see how we go. So the first thing that we need to do is get this Simplex Noise plugin working. Now, I accidentally closed my project. Hang on, that's the wrong one, so let me just open that back up. Where are you? Minecraft. I had a bit of trouble trying to get this plugin working when I was trying to figure this out, so fingers crossed we can get this working all in one hit without too much back and forwards. But what you're going to need to do is you're going to need to get a you're going to need to download the Simplex Noise plugin from the internet, so I'll put a link to that in the description. So you'll download that, and what you'll get is this folder here, Simplex Noise, and it's got all this stuff here just inside of it. But I'll show you what to do with that in just a sec. We need to do one thing first. So inside of your project, the Minecraft project that we worked in the last video, we just need to go File, New C++ class. We're not going to be using any C++ in this tutorial series, but we need to generate this to get the plugin to work. So I don't know if it matters which one we use. I think we can just go none. I'm just going to call this, my class. I'm not going to change anything, honestly. Let's just create it and just see what happens. The reason that we need to do this is because the engine needs to generate C++ files in order for the plugin to work, I think. I'm not 100% sure because I don't have any idea how to use C++, but yeah, I'm just going to give that a second. Maybe I'll cut the video. Okay, so I think it's finished creating the class. It's just doing some shit down there, loading Visual Studio, whatever. I think I am right to close that right now. So after that's done, I can close that. I am going to close this because this way seems to open when I close Unreal. I'm going to grab my Simplex Noise plugin. So this one here that contains all of this. I'm going to copy that. I am going to navigate to my project folder, my Minecraft YouTube tutorial folder. And you may or may not have this plugins folder. I can't remember if I created this in this video or not, but let's pretend that isn't there. What we need to do is we need to create a plugins folder. Spell it just like that with the same capitals and things, I think. I think it needs to be the exact name, although I'm not sure, but create that and then paste your Simplex Noise in here. And I'll just give that a sec. Okay, so that's in there. Okay, so now that we've got that plugin in there, we're going to go into our saved files. I'm just going to delete everything in there. And also in the intermediate files. Sorry, my computer's going a little bit slow. It's trying to do so much at once. So we'll delete those, everything in that too. Okay. So we've got our plugin. Come on, you can do it. We've got our plugin. We've deleted the saved files. We've deleted the intermediate files. Now I believe we want to generate the Visual Studio files. So if we right click on here, this is our project, our U project. This is the one that you double click to open the project. And we want to say generate Visual Studio project files. I have no idea how long this is going to take, so I'll probably just cut the video here again. Okay, so I think it's done. It didn't take as long as I thought it would, but I believe now that that's done, we should just be able to open the project and it should work. Well, after we open it, it'll give us a prompt that'll tell us that we need to build the plugin or something, and then after that it should work. Let's just wait and see. Okay. So it's loaded up. It's telling us that new plugins are available. I don't think this has anything to do with what we just did, so let's just ignore that because those are just my engine plugins. Now, our green on our Minecraft has disappeared, and that's because we deleted the saved and intermediate files, I think. So let's just recolor that because that's very important. Let's go to our map. So the way that we test if this has worked is let's go to our chunk BP, and we should have access to a add noise function now. So let me just dock that up there. Add noise, no. Simplex Noise, here we go. I had a little heart attack then, I thought it didn't work. Okay, so because we've got all of these functions here, that's shown us that the plugin has worked. And I believe this is the one that we're going to be using today, Simplex Noise 2D. So I'm just going to compile and save that. Let me just have a quick look at what we want to do first. Okay, so now we're going to be generating the 2D terrain, now that we've got all that out of the way. I'm just going to split these videos, hold up. Okay, so the way that this Simplex Noise works is it takes in an X position, it takes in a Y position, and then what it does is it outputs a noise value depending on the positions that you've given it. And that noise value, the important thing about it is that it's continuous. So it has, I think, a maximum value of 1, a minimum value of -1, and at any given point in between you can infinitely sample points next to each other and it'll always produce a smooth curve. So for the case of our terrain, if we sample block positions next to each other using the X and the Y, the outputs that we're going to get from here are going to be similar if those points are next to each other in here. So that's how we get nice, smooth, flowing terrains. So to get this working, we have an X loop, we have a Y loop, and then we have our add instance thing. So what I might do first up is just move all this to the construction script. I know I said in the last video that we want to have it at begin play for like staggering things and performance, but in the construction script it's going to allow us to see it in the viewport over here before it's actually been generated, without actually playing the game. So that's going to be helpful just for debugging. So I'm just going to copy and paste that all into the construction script. And what I also might do is I had numx and numy here. I'm just going to call this num, just straight up, delete the numy, and then delete the numy down there, and just put num in here like that, because this doesn't need to be different for X and Y. Like, it's just going to be a square chunk, so we only need the one variable. So that's just going to keep things tidy down here. So now that we have our instance, our adding instance thing here, let me show you in the viewport what we've got. So this is how our chunks look at the moment. Now what we need to do is we need to get this noise function working. So I'm just going to delete that in there, delete everything in begin play in the event graph. Compile, save, go back to the construction script. I'm going to get rid of our Z value thing that we had set up down there. So now we should just have smooth terrain, just like that. And what we will do is we'll add our Simplex Noise 2D function in here. So the way that this is going to work is we need to get the world position for each of these cubes and then feed that into this X and the Y. That's how we're going to get continuous smooth terrain. It needs to be the world position, because what we want is we want to use this function to generate continuous curves from chunk to chunk. So if this is one chunk and we want another chunk here, if we're just using the local coordinates of the blocks, then we're just going to get the same repeating pattern of chunks. But what we want is a continuous noise function across multiple chunks. Hopefully that makes sense. So the first thing that we're going to need to do is probably get the actor location of the chunk. We're going to divide that by a float, and that float is going to be the voxel size. So what this is going to do is convert the location of the chunk in the world into essentially coordinates of the chunk in a voxel size coordinate system. I can't think of a better way to explain that, but let's just roll with it and maybe it'll make sense as we continue to work with these values here. So we're going to grab our loop x and our loop y's. The reason that we do this here is because it essentially converts this value into something that's compatible to use with these loops. So let's break this. We'll break the vector. The z isn't important just yet, or maybe it will be, I'm not sure. Let's floor all of these. Floor these. And what we might also do is, instead of calling these loop x and y, let's call this local voxel pos for position y, and local voxel pos x for that one there. Okay, and what we're going to be doing is adding these local positions to the world position of the actor to produce the final world position of each voxel, which will feed into that. Hopefully that makes a bit more sense. So let's add these together. We're going to need to do this for a Z later too, actually, for the 3D noise. So maybe what we might do is we might just add a third loop in here, just like this. So I'm just going to copy that, put that in. That can go. This can also go, and we're going to need to create a new variable which is going to be called depth 2n minus 1, just like before, and I'm just going to put that up next to the num. Maybe num isn't a good term, maybe we should say like width, or no, I'm just going to keep it as num, because width kind of implies that there's also a length. So let's grab the depth and set that up in here, and this is a loop just like we did with the other two, and I'm just going to label these really quick. So we're going to have x, we're going to have y, and we're going to have z. And off of here we're going to have a local variable and call this local voxel position z. Okay, compile and save. And now what we can do is we can grab that local... Oh, I made it a local variable. Whoopsie daisies. We want that to be a normal variable. My bad. Local voxel position z. Okay, so let's put those up there. I'm just going to rearrange that to there, drag this in, control drag in, and copy this add node. The x value is being added to the x local position. Let me just rename that to pos, because position, I want them to be the same. The y can go into the y, and then for the z, that can go into the z, just like that. And now what's being output by this is essentially the positions of these voxels, or the coordinates of these voxels in world space. So we could even promote these to new variables up here, and I'm going to call this world voxel pos x, and I'm just going to do that the same for the rest. So you can probably fast forward for a sec if you want to skip watching me do this. World voxel pos y. And duplicate, and this one can just be world voxel pos z, and then alt drag that in like that, and plug that into there just like that. Now This world voxel pos z, we're actually going to need to rename that so that it's slightly different. I'm going to put it pre-noise on the end like that, because it's the world position of the voxel for the sake of generating 3D noise, which we're going to be doing later. And then afterwards, once we've generated the noise, we might need a post noise z for things like determining whether or not the material should be snow if the post noise z is up high, or if it should be dirt if it's low, or etc. So it's important that that's pre-noise. Now I might just drag this all out just a little bit to keep this neat, because this does get quite complicated. So I'm just going to call this loops. I'm going to call this set voxel coordinates brackets pre-noise. Okay, and now we should be able to generate the noise. So let's drag this out like that. Just give ourselves maybe a little bit more space, because we might want to do some maths in here. Okie dokie. So for the noise, let's grab our world voxel position x and our world voxel position y. Now we're going to multiply them by a float, and the float that we're going to be multiplying them by is the voxel size, because that's going to convert the position in our voxel space, our imaginary voxel grid space, to the world space, just like we did in the last video a heap with the chunks. So we can do the same with the position y as well. And actually that's probably all we need to do. So we could just plug those into x and y just like that. Now the in factor, I believe this is like a noise density. So the larger we make this, the more chaotic the outputs are going to be from here, or the more like dense and like staticky they're going to look. So for example, if we, well, let me just promote this to a variable and we'll deal with it in a sec. Let's call it noise density. Maybe I could even just show you what it does. That's probably the best way. I'm going to make that public too, by the way, because we're going to play with this. I think a good value to use is like 0.005 or something. And then the output of this, what if we just go multiply by float for now, and we can have another variable here, and we'll call this noise scale, which can also be public, and then we can just plug that into our z down here. I'll tidy this up in a sec, but let's just get this working, and then we can tweak some of the variables in a sec. So the noise scale, this is taking a value that's between 1 and -1, and then multiplying it by however high or low we want our voxels to be going. So let's just set the default of that as like 10, and the noise density as whatever that is. Now in the viewport, what have we got? Nothing just yet. I think what we also need to do is probably multiply this by the voxel size maybe. What if we try that? What's going to happen? Okay, so now we get this crazy thing. What if we reduce the noise density? What happens? Okay, so you can kind of see that we're starting to get a vague outline of some curves, but it looks like the density is still a bit too high, or perhaps maybe the noise scale is just a bit too high. So maybe we should just reduce that to 1 for a second. I think this needs to be set, we need to multiply it by the voxel size, because that's gonna, oh, we might actually need to round this first actually. So maybe let's floor it. We'll floor that value, and then we'll multiply it by the voxel size, and then, oh, actually maybe we can floor it last. Let's floor it last. The reason that we want to floor it is because we don't want, this here can return non-integer values, and then when we're setting the position of the instance, this needs to be a perfect multiple of the voxel size, otherwise the blocks aren't going to stack neatly. So what do we get now? Okay, so you can see that we kind of got noise, but that last thing that I was saying about them not stacking neatly, we want these to be you know, like a three-dimensional grid. We don't want them to be so smooth. We want them to be like on top of each other. So give me just a sec. I'm just going to take a breather and figure this out, and I'll get back to you. Okay, so I just cut the video because I needed to figure out a few things that went wrong. So this is what my Simplex Noise setup looks like right now, and I've just deleted everything that's after it. So there's no longer anything connected back into the Z. The Z over here is just set to 0. So what we need to do is, this is returning a value between 0 and 1. So we're going to multiply this by, let's multiply it by an integer. And this integer is what we're going to be making our noise scale. So I'm going to delete the old noise scale we have down there, promote this to a variable, and call this noise scale. And that's going to be a public variable. Now let me just compile and save that, and just double check that I'm recording. Yes, I am. The reason we want this as an integer, because this is going to be a noise scale in blocks, like a number of blocks. You set this to 5 if you want the peak of the noise to be 5 blocks high, or set it to and 5 blocks low, because this returns a value between 1 and -1, which is then going to be multiplied by the scale. So the scale is going to be between positive whatever you've set or negative whatever you've set. Okay, so now I don't think we will need to round that anymore, will we? I think, will that even be fine just like that? Oh no, we will need to round that. Yeah, will we? I'm not even sure. Let's just round it anyway and just see what happens. Round, plug that into here, and let's just see what happens. God, am I that bad at this? Oh no. Okay, so after we round it, well, do we even need to round it? I don't know. What we need to do is, this is returning a integer value. Well, yeah, this is returning an integer value here, which is in number of blocks. So then what we need to do is, we need to take our number of blocks and then multiply that by our voxel size, and then use the output of that as the world coordinates. You can't use the number of blocks as the world coordinates, because that's just going to result in tiny changes. So now we get this. Okay, so what I might do now is, I might, instead of rounding it, I might floor it and see what happens. Because it looks like we had a few gaps, because some might have been rounded up and others might have been rounded down. So what happens if I floor it instead? Yeah, we still get some gaps. Okay, so what else could we do? We could reduce the noise scale to maybe like 4. What do we get? Okay, it's looking a little bit better. What if we take the noise density and maybe reduce that 0.0005? Okay, so now we're getting something like that. Now we're getting somewhere. We still have a few gaps in there, but what if I reduce the noise scale again to maybe like 3 or something? Okay, so now we've got some smoothness. Now, just for testing purposes, why don't we crank up this number to maybe like 20 and probably crash the engine? Oh no, okay, we're good. Okay, so now we got this. So now you can see this is starting to look a bit like a Minecraft terrain, but it's still a bit too cluttered for my liking. Okay, and that's starting to lag a little bit, so I might just reduce that to like 10. Okay, because this is fine for now. So what we could do, our noise scale, what if we bump that up? We can bump that up to 5. Maybe the density was a little bit too high still, or what we could do over here perhaps, yeah, what if we just reduce the density even more? So 0.0001, and just see what happens. Okay, that's nice, that's nice. And if we were to change the number a little bit to maybe 20 again, yeah, we start to get big long curves like this. So the best case scenario for this, which I'm not going to do right now because I kind of want to move on, but you can actually combine multiple passes of this noise to get much more interesting terrain than just this. So this is kind of like a big slow hill with a pretty high magnitude. What you could also do is have that first thing that we had. So if we were to change our noise density back to 0.01 or something, and our noise scale maybe down to like 2, you could have something like this superimposed on top of your other noise function, or like it could be less extreme than this. Like you can change it so much, and you could add so many layers, and you could have different combinations of different noise for different biomes and all kinds of crazy shit. So for now though, let's just reduce this back down. Let's change our noise density to 0.0001 so that it's nice and smooth and rolling, and let's make our noise scale something like 4. Okay, so this is working, so let's just tidy this up just a little bit. So this here is outputting something that we're going to promote to a new variable and call this world voxel pos z post noise. That's what this is. This is the coordinates of the voxel after the noise has been applied. So we can leave that like that, and now this thing over here, this is going over here to where we're adding the instance. And what we're doing when we're adding the instance is we're just using the local position y, the local position x, because this is in local space, and then we can use this world position z here just like that, and that should be fine because everything's just at 0. Everything's based around 0z. I'm just kind of rambling to myself, and not a whole lot of that makes sense. Oh, and that's not going to work anymore. What did I do? Oh, there we go. We need to plug that in. Okay, so the post noise multiplied by the voxel size, and we get our terrain back. Okie dokie. Now, how long did that take? 6 minutes. Not too bad. What's next? So I think we've done all of this. The loops, voxel units, world position of the chunk, feed them into the noise function, multiply by the scale, and use the z. Sure. So now we can add some depth. Let's add some depth to this. So for this loop here, oh, depth was already set to 5, but we weren't getting any depth. And that would be, oh, maybe that could be why it was lagging so much before. This is actually 5 blocks all superimposed on top of each other in every single spot. So if I reduce that down to 0, we should be able to get some larger numbers without it lagging so much. Yeah, look at that. That loaded way quicker than last time. What if we go 50? Yeah, not too bad. Look at that. Ooh, that's fresh. Yeah, it's still a bit slow compiling. Let's go back down to 20. That's pretty good. Let's roll with that from now on. Okay, so to add some depth, what we will need to do is probably use this value here instead of this one. Give me a sec. What we will do before we set our post noise value, this is essentially the final coordinates of the block that we're going to be placing in the world. We're going to take the output of the position generated from the noise. We're going to be subtracting off an integer. Let me just rearrange that so that our post noise is right next to our pre-noise. And we're going to be subtracting off our local z, just like that. So as this loops through and the local z changes and increases, this number is going to be increasing, meaning that the position of the blocks, from the output of the noise is going to be getting lower and lower and lower and lower and lower as it goes through the loops. So we can plug that up into there just like that. And at the moment I don't think that'll do anything because we have it set to 0, so it's only doing one loop. Our depth is set to 0, so it's only doing one loop. But if we set that to 2, there we go, now we got some depth. Now this causes the performance to drop a lot because, as you would have seen before, when we had like 50 blocks just on the surface, it was starting to lag. But now we've got 20 on the top, 20 in the next row, 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 so it gets fucking hectic really quick. But we can try and get a little bit of depth without it being too bad. In the actual game Minecraft, instead of using blocks like this, I'm pretty sure like the meshes are like rendered when you're looking at them, so only the faces that you can see are being shown. So all of this shit in the middle isn't actually part of the game until it's like relevant to you. So that's why this lags so much in Unreal, because you look at this and all these blocks in the middle that aren't even like visible are still being rendered. But what we can do is we can build an algorithm later where we can check these coordinates here and see if they're encompassed by other blocks. So like a block down there like that, we could do a check with each of the neighboring blocks and see if they're occupied. And if they're occupied, then we can not spawn that block, and that does increase the performance just a little bit. So maybe we will get to that eventually, but let's finish off this other stuff first. So I'm just going to change the depth back to 0 for now because we're still doing 2D stuff. I think, or are we done with the 2D stuff? I'm not even sure. I'm just going to comment this and call this whole section here with the simplex noise and the world position with the noise. I'm just going to call this calculate noise. And then later we can come back and add multiple parts. I might call that just calculate noise. Calculate 2D surface. Oops. God, I cannot type today. Calculate 2D surface noise, because we're going to be doing a 3D noise in a sec. And then this one over here is going to be called add block instances. Okay, compile and save. So we've got the depth done. Now let me just see what we had to do next. So loop Z to add depth. Set everything from the player controller. Yeah, let's do that. That's probably a good idea. So this numx, we want that to be exposed on spawn. Depth, we want that to be exposed on spawn. Voxel size, let's also expose that on spawn. Is that actually working, the voxel size? I'm not, like, is that scaling everything properly? Let's check. So if I change this to 300. Oh, that's interesting. We got a different pattern that time. Yeah, anyway, that's cool. So, I mean, it seems to be working. I guess now because the positions that we're feeding into here now are different, because this value here, when you have a larger voxel size, it produces a different world position, so we end up getting a different pattern. That's fine. So that's working. The voxel size is working. The noise, did we check that? Expose on spawn? Yeah, we need to make that expose on spawn. Noise density, let's expose that on spawn for now too, and the noise scale can be exposed on spawn. And now what we can do is we can go to our player controller, and in our function down here, spawn new chunks within render range. Let's just go into that, should spawn a chunk, spawn a new chunk at the loop's coordinates. Here we go. So now we have access to all the variables down here. So when things are in the construction script of this, it's cool to be able to have access to these just to play with this and see how it looks. But maybe when we actually generate the world and all these chunks are connected, we want to have separate world parameters in here, just for managing things like performance and that when there's a lot of chunks on the screen. So let's go ahead and just promote all of these to variables. So I'm going to call this width of chunks, depth of chunks, chunk voxel size, chunk noise density, chunk noise scale. And I'm going to compile and save, and what I might do is I might add all of these to a new category, which are going to be called world gen. So the chunk size X and Y is going to go in there. What the hell is that again? I don't even remember. God, the render range can go in, and all this stuff that we just created can all be public, and that can all go in there. Okay, compile and save. I should probably drag all these out so they're a little bit neater. Okay, I'm just going to take a little break and think about what I need to do next, and I'll be back. Okay, so I think I remember what our chunk size was. That does not need to be public, because that's referring to the size of the chunk which is used to calculate where the chunk should spawn, and that is actually going to be determined by the voxel size of the chunks multiplied by the width of the chunks, because the width of the chunks is in voxels. So I might just put in brackets voxels down there, so we know what the units of these are. And render range here, I might put that as chunks, just so we can tell. Chunk noise scale as well, voxels. It's good to include the units there. Okay, so what that means then is our chunk size. Instead of setting that manually like we did in the last video, let's go to our event graph, and then on begin play, let's add a new function which we will call initialize, because we might set a bunch of parameters in here later on. Let's set our chunk size, and the chunk size is going to be the width of the chunks multiplied by a float, and the float is going to be our voxel size, and that'll yield the chunk size. Okay, so that should be set automatically now. And we chuck that in, chuck initialize in on begin play, spawn new chunks within the render range, and then each tick we're going to be checking if our coordinates have changed, or if they're the same rather, and if they're not the same, then we're going to run the change coordinates event, and then we're going to be spawning chunks. So I might just comment this and say player has changed coordinates, event tick check if player has changed coordinates, and then up here I'm going to comment this and just say begin play, initialize and spawn starting tiles. Okay, I wonder if this will work. Let's see. I'm just going to change that to new editor window, and what the hell is going to happen? Fingers crossed. There we go, baby. It's done the job. We've got our Minecraft world. So you can see now, actually I might just exit out of this. I should have taken a moment to bask in that glory, because it actually it actually worked, and that feels good, man. I'm just gonna grab my player character movement and just grab our, I might increase our jump velocity to 1200, and I might also get our walk speed and just change that to like 2000, so we can run through the world really quick. Alright, compile, save, play, give it a sec while it freaks out and loads the world in. I'm just gonna put our frame rate in. The way that you do that is you type the little squiggly icon on your keyboard next to the 1 and just type in stat space FPS. Oops, I just lost it. Shit. Okay. So yeah, look at this. We're running through, and you can see that the world is smooth and continuous. Now he's very floaty. God, this is hard as hell to control. But yeah, look at that. We've got our Minecraft world, and we can tweak the things like the render range and things like that. Now, as you can see, the FPS drops as you approach the edge of the map, and that's because what it's doing is it's spawning in a bunch of new chunks. So we can fix that up and optimize that a little bit later by staggering the spawning so that the drop doesn't occur so dramatically. But for now, this is pretty fucking good. Like, that looks pretty nice. So let me close that player controller, third person player character. You know, I think that's all pretty good. Like, we could play around and see how big we can make it. Should we do that? Yeah, so player controller, render range. Maybe we can make the render range like 5 or something. And let's go back to the noise density, and maybe let's reduce that again. 0.00005. God, that just seems really low. I wonder why. I don't remember it being that low when I was making this the first time. But oh well, if it works, it works. And this time it crashed because we had too many blocks, too many chunks. So let's try 4. Fingers crossed. Yeah, okay, that's good. So look at that. The world's quite long. Like you can see quite far into the distance. It's still got that lag when it's spawning them in, but oh, you know what we could do actually? Instead of having such a big render range, why don't we drop that back to 3? We could change the width of these chunks to maybe 30. That might be too big actually. I have no idea what's going to happen right now. Probably crash. Let's just see. Okay, no, that works as well. And we could make these hills bigger by changing the noise scale if we wanted as well. Yeah, okay. So that's our Minecraft world. Now, what the hell are we going to do next? Let me just have a look. Okay, so we tidied everything up. Now we can add dirt, grass, and snow. I'm just going to cut this video again and I'll be back. Okay, so to do the different block types, what we're going to need is we're going to need several different instant static mesh components for each material. So each instant static mesh uses the same material for all the meshes, which is much better for the performance than using a different instance of a static mesh or a different static mesh component for each block. So in order for them to all share the same material, we need to have, if we want different materials rather on each of the different blocks, we're going to need different static mesh instances. So what we will need to do is let's have a for each loop. We're going to need a new variable which is going to be called block material types, and this is going to be material object reference. There are better ways to do this with data tables and things like that, but I'm not going to go into too much detail here because I want the emphasis of this tutorial to be on random world generation. But this is going to be of type array. It needs to be an array, so change that variable type, which is going to do some stupid shit because I have one of these in the editor. Connect that up to there. Now for each type of material, oh actually let's set these defaults real quick. Let's add some elements. We'll have a grass one. We'll have a rock one. Which one looks cool? Let's grab that rock one just like that. And I don't know if we have ice. I don't think they have that in the starter content. Do we have one that looks like kind of icy? Maybe like concrete. It looks kind of snowy or some shit. So that can be used for the mountains. Well, I guess that's kind of cool. Like you have this white sort of stone at the top of the mountains. Maybe we could have. Oh no, I'm not gonna worry too much about it. Now for each time this fires, we're gonna create a static mesh instance. Can we do that? Or add component rather. Add component instanced static mesh. This one. That's what we want because we're adding these components up here. Which means we could actually probably delete that. Let's keep that for now because I've got a feeling I might need to use that for something later. The transform doesn't matter. Manual attachment doesn't matter. We will need to set the mesh to a cube. So I think we use this 1 meter cube, so we can set that just like that. So we're adding a static mesh for each material type. And then what we're going to do is we're going to set the material. And this is the important bit. Set the material to the array element, so that just gets plugged in under there just like that. And that should be all good. So we could probably collapse that to a function and just call this initialize. Initialize. And then plug that into there. So that'll happen in the construction script right when this thing is built, and it's going to create all the material types that we need. Now the last thing that we will do is we're going to actually need a reference to each of these components. So let's say add to array, plug that into there, and then off of the array bit we're just going to drag out and call this isms, instant static meshes. That'll work. It does the job. And I think that's all we need to do there. So let's go back to our construction script, and now that we have a reference to those isms, over here where we add the instance at each of these points, we're going to change which ism we use depending on some different height rules. So we could use a select node here. Or do we want to use a select node? I'm not actually sure. Maybe what we can do is, let's drag this self pin all the way over here and add a reroute node. And then I'm just going to collapse all of this here into a function. And call this add instance static mesh instance. Or let's say add voxel instance of type. Maybe I should just clarify as well using world pos. And this can be just called instance static mesh to add. Hopefully this makes sense what I'm doing. Okay, so we can delete that, and now what we're going to need to do is probably have... Should we use a switch? I'm not actually sure. Let's just use a branch because it'll be easier to illustrate. So I'm going to delete that comment real quick, and we're just going to grab our probably our world Z post noise, and we're going to say, is this greater than I don't know, let's say like 5. If it's greater than 5, we're going to add we'll have to say get copy here, get a copy of our instance static meshes. If it's greater than 5, we'll grab the first element of that, which was grass. No, we don't want that. We want, if it's greater than 5, let's grab the concrete one because that'll be at the top of the mountains. So index 2. And now we can just copy all of this. Is there a better way to do this? There's got to be a better way to do this. Oh well, doesn't matter. Let's just roll with it. Maybe I'll think of a better way to do this and we can come back to it in another video. So the second case is if this is maybe less than 5, we will use dirt, which was, or rock, which was 1. So we'll use index 1. And otherwise, if it's neither of those, we can just use grass. So that'll be 0, just like that. And then we can comment all of this and say add ism type depending on block height. Okay. Compile, save, viewport, and everything is the one color. What happens if we play in the world though? We get an infinite loop. Okay, so let me just reduce everything a little bit. So in the player controller, the render range can be 3, that's fine. The width of the chunks, let's just reduce that to like 10. Depth of the chunks can be 0, voxel size 300, density is fine, noise scale, oh, the noise wasn't big enough, so let's maybe make that, like, I don't know, maybe 7 or something, so that way we get some above 5 and some below 5. Let's just see, fingers crossed this will actually work. Okay, there we go. I mean, it looks like it is kind of worked. Oh, this is the starting bit right there. So if we run over here, oh, we have some random blocks out in the middle of nowhere. Oh, that'll be because I didn't delete the the original instance static mesh. So at the top, up there, if I can even get up there, Jesus Christ. You can see up there we have a different type of material, even though it hasn't rendered in. So that would be our snow material. Now, if we can find a spot that's low enough, we should be able to get another material. I wonder if I can, because oh no, this dirt one was meant to be the other material. Okay, so we're not getting the grass in there. I should probably do shorter tutorials because my brain's like freaking imploding. If the Z is greater than 5, add the rock one. If it's not, is it less than 5? Less than 0, let's say. If it's less than 0, add the dirt. If it's not, then make it grass. And let's see. Okay, so that must be our grass up here. It just looks like it hasn't rendered in. So I don't know how to fix that, but I think I do know a workaround. So if I go into here and we look at this instant static mesh here, what if I just disconnect all of this for a second? So that should all disappear except for our one single block just here. If I type in grass, I think this is it rendering it now. And then if we use grass on this actor, it may render properly in the game. Sorry this is such a long tutorial, holy shit, like I feel like I've been going for ages. We'll get to that cave generation stuff soon, and maybe I'll add some timestamps in this so people can skip through and just go to the bits that they want, because not everyone came for trying to get materials to work. But just bear with me, we'll get there. You gonna work or what? Okay, so I fucked around with materials for a while, but I couldn't quite get the ones I wanted to work for some reason, but I found that moss does work, rock does work, and the basic wall, all in the starter content, do want to render. I couldn't get grass to work, I couldn't get the concrete one to work, it just kept coming up with the default one. So if you have a solution for why that's the case, can you please drop me a comment, because I don't know anything about materials and I would really like to be able to set materials at runtime and not have that stupid default material show up every single time. But anyway, the other things that so this is what it looks like right now, by the way. None of these are greater than 5 at the moment, so we can't see any white, but I also deleted the old instant static mesh up there. That can go right now, so you can get rid of that in your project as well. In the construction script, I'm just going to change, let me just comment these just so I can remember which one's which. This is going to be snow, this one is dirt or rock, and then this one down here was grass. So if we're greater than, let's say, 4, snow. If we're less than -4, let's go dirt, otherwise grass. Compile, save, and now everything is grass for some reason. Oh boy, today's not my day. Can I increase the noise scale? Oh, the noise scale is 4 here, so what if we change that to like 6? There we go. Okay, we got there. We got there in the end. So maybe 4 is a bit too much. Let's say 3 and -3. Compile, save. Yeah, that's lush. Look at that. So we can roll with that. I could use that as my thumbnail, honestly. That looks pretty fucking good. Okay, so that's working. And if we try it in the world, we have a noise scale of 7, we have our density, render range, and etc. Let's just try this in the world. Okay, here we go. That's looking pretty good. That's looking pretty good. So we have our rock down here, and we have some snow up there. You can see the snow up there. Now it is very laggy, but that's alright. Well, it's not laggy usually, it's just laggy when we render in new tiles. But we'll get to that. So here's the snow. There we go. Check that shit out. That's pretty good. I am going to just check what we need to do next. So the last thing that we need to do is just set up the 3D noise. Okay, so as you've probably guessed, this isn't going to perform too well, because we tried to add depth already, and as soon as we start adding depth we start to get a shit ton of lag. But let's build this anyway and just see what happens. So let's go into the... Actually, let me just pause real quick because I'm going to save that as a thumbnail because it looks cool. Okay, so the last thing that we need to do is just set up the 3D noise. So to do that, this is just me taking a fucking sick screenshot for the thumbnail. Let's go back to the construction script. Calculate 2D surface noise. That's all fine. That's determining the voxel position, and then this bit over here is changing the type depending on the height. What we can do in here is we can have another check to to see if we're below the surface, and if we're below the surface, then what we're going to do is we're going to cull blocks and just not spawn them if the noise is below a certain threshold, so that we can get caves. So the first thing that we need is we're going to need a branch, and we're going to grab our loop, our local Z maybe, and check if this is less than, if it's less than our actually I think we want to go negate. Let me think about this. No, actually this is fine. This is fine. If it's less than our where is it? The depth, I believe. I'm not actually even sure anymore. God damn. If it's less than the depth, then that means it's less than the final loop, and the final loop is on the surface. So if it's less than, we're going to add noise. If it's not, we're just going to go and do things as per usual. So let's just put that down there just like that for now. We're going to go 3D Simplex Noise into the coordinates. For the noise, we're going to be doing the same thing that we did before. We're going to grab these two just like that. Doop, doop. And then what we need to do is get the post noise value here. And we're going to be multiplying that also by the voxel size to get the world position in Z for that there. Now, noise density. Let's have a 3D noise density as a separate variable. 3D noise density. Let's make that a instance editable one, and also expose that on spawn, and compile and save. So that's fine. Let's copy the density that we used for the last one, which is what, 4 zeros and a 0.5. So let's go 0.0. Oh, actually, we might need it different for this one. Let's try 3 zeros and a 0.1 and just see what happens. Now, this output of this value, we're going to check if this is let's check if this is less than or equal to some threshold, which we're going to call 3D noise cutoff threshold. Let me just capitalize that T in there because I'm a freak. Not really, I just like things to be neat. So let's put a branch. So what we're doing here is this is checking if we should begin culling blocks for 3D noise. And it needs to be less than the surface one, because if it's not, we always want the surface. We don't want the cave spawning at the surface. Or maybe we do. We can play around with that later. But let's make sure that they're spawning lower than the surface. Generate noise. If the noise value, which is going to return a value between 1 and -1, if it's less than the threshold, noise value less than the threshold. So is noise less than the threshold? I just noticed I sound like that Khan Academy guy. You know how he repeats himself as he writes stuff? I don't know if you probably haven't heard of him, but I used to watch him when I was in school. He used to teach me a lot of chemistry and physics and stuff. It just sounded so similar. That freaked me out for a second. So, is the noise less than the threshold? If it is, we're going to do nothing. If it's not, then we're going to go ahead and just spawn our normal block. The threshold can be 0 for now, because this is returning a value between 1 and -1, and the noise density can just be that. So in the viewport, nothing will happen yet because we don't have any depth. But let me just reduce this real quick to maybe like 10, so it's nice and thin. And now let's add some depth. Fingers crossed. Oh, interesting. Look at that. That seems to have kind of worked. Did it work fully? I'm not even sure, because it looks like it's cut it right down the middle, which makes me think I needed to negate something, or... No, it actually looks like it might have worked. Okay. So what if we add some more depth? Let's go maybe 15 depth. Please don't be too much. Ooh, okay. That's looking good. And now you can really see those height rules coming into play. You can see above the value we got that, in the middle we got that, and below we've got that. This is going to make a good screenshot as well. Hot damn. Good thumbnail for the video. I might play with the noise density. Let's increase this a little bit. So 0.00001 perhaps? Ooh, that's chaos. That's too noisy. So that's what too much noise looks like. It starts to look crazy as fuck. Like it's just too dense. Like the variation is too much. So 0.005. Let's try that. Okay, that's looking good. That's looking good for caves. See this? Yo. That's looking cool. And of course you can play around with this. You can do whatever you want. You can have it spawning using different parameters depending on, you know, like biomes and things like that. But this is the basic idea. Oh, that's awesome, dude. That's awesome. I'm so glad that this is working. I'm just gonna scroll around this for a little while. I always shock myself when this stuff works, you know? Like I'm always like slightly amazed. Oh, look at that. That's beautiful. Amazing. Okay. That's basically the 3D noise done, actually. That's all we needed to do. It's really that easy. Like, you'd think that this would be complicated, but like it's really not, like, at all. And we've still got the surface up there as well. Actually, it looks like we've deleted the surface somehow. I wonder why that is. I'll deal with that in a sec. Let me just show you one more thing. I just clicked that by accident. So the cutoff threshold is also another public variable. Let's compile and save that. Let's say we want really wide caves. We would change the cutoff threshold to maybe 0.5. Yeah, so now we get a very small number of blocks because most of the noise... Oh, I see what's happened. It's only generated the floor instead of the top. But anyway, what I was saying was that could actually be useful because you could use that as bedrock. If the player was digging through the map, you could have an unbreakable layer on the very bottom so that they can't dig out through the bottom. Anyway, so if the noise generated by the Simplex Noise 3D is less than 0.5, then it's going to cull the block. So if you wanted to really kill it, we can change it to 0.9, and now you see we've got fuck all. And if we went the other way and changed it to negative 0.05, oops, sorry, that's not what I was going for. Negative 0.5. If the cutoff is negative 0.5, now you can see we have mostly blocks spawned in, and there's only just a few little gaps here and there. But they're all still together, which is kind of cool. Like you could hide things in there. This is the cool thing about the noise function being continuous. So maybe you could use like a low value like this on the surface, so you get things just like that. And then as you drop below, you could use a noise threshold value of, maybe that's a bit too high. You could begin to use a noise threshold value like that, so now it starts to connect to caves. So on the surface it'd look like this. Just like that, few holes. And then once you're inside, oops, 0.5, it'd begin to look like this, where you've got these massive gaping holes. Okay, so let me just fix that this bottom thing down here. We want that to be spawning on the top and not the bottom. Why is this all backwards for? Oh god. Okay, so is the local voxel position less than... What if we just change that to a greater than? Will that do it? I can't be bothered thinking about this now. Oh no, because that'll make it everything but. So what if we try... I don't even know, bro. I can't even be bothered thinking about this. What if we just apply the noise to everything? There we go. That's fine for now. I might just take a break and see if there's anything else that I need to add to this, and then I will come back and I'll finish this off. So I just quickly tidied a few things up. Oh, that's not tidy. What the fuck am I talking about? I fixed up my little check thing, so this is what it looks like here. It's just doing a check, is this the surface, and it's checking is the local loop position of the voxel, which is being negated, is it greater than some value that I've defined there. I'm not going to explain this right now because I don't even really understand it myself. It's just I played around with it and I got it to work, but this is what it looks like right now. So the value of 3 is just 3 blocks below the surface. Is this the surface layer or 3 blocks below? If it is, then make this the surface. If it's less than, start to do caves. So that's what the check looks like. False just has the thing just like before. Is the noise less than the cutoff threshold? True, cut it off. False, spawn a block. And now I just thought what would also be cool is we could have a different noise function for the surface, just like I was explaining before. So to do that, we can drag this noise cutoff threshold out there. We might also have to actually drag this out just like that, and we can collapse this here to a function which can be called apply 3D noise. Just like that, and this here can be the noise cutoff, and the return value can be is it less than, so should cut, yeah, it'll be should cut off. Alright, compile save. So then what's going to happen now is if should cutoff returns true, this returns true, and then nothing happens and it's cut off. If it returns false, then it will spawn. Am I recording? That just seems like the kind of thing that I'd forget to do right now. But let's bring that all over a little bit closer so we could have this exact same thing up here, and we could have a surface 3D noise function up here. Should cutoff false, we'll go ahead and spawn. Now the noise cutoff for the surface can be something lower, so we can have point. Oh, actually, what if we just grab our other threshold and just times that by a float and multiply that by -1, so we can just negate it. Oh no, that's too fiddly. Let's just make this 0.5. So now we should get a different noise threshold on the surface to below. So below we got crazy ass gaps and caves. On the surface we just have a few holes here and there. Maybe we could make it even less, you know. Or even what we could do is we could also grab this noise density, and we can make that noise density, and we can change that as well if we wanted, even though I'm not sure that's a good idea because that might cause things to fuck up a little bit. Oh well, it's out here now, so I'm just going to leave it. Noise density, that's fine, just like that. I might make you -0.7. Compile, save, and I'm just going to comment all of this and say, oh, what the fuck just happened then? Holy shit. Go back. No. Yes, good. Okay. Apply 3D noise. Surface 2 noise, so apply 3D noise for caves. Just like that. Now, at the moment, if I try and run this in the world, yeah, so that's better. Look at that. Now we've got these little gaps in there. It would be cool to have them a little bit bigger, but I'm not going to tweak this all day long. But once you go through the little gap, you get the idea. The caves expand once you're down here. Okay, so. Putting this into the world. I'm actually going to change that to 0.5 because I can't stop thinking about it. I liked it when it had the big gaps on the surface. Yeah, cool. Now putting this into the world, this at the moment, like it's much too big. Like this will just cause shocking performance. But do you want to try it anyway? Let's try it anyway. Width of the chunks can be 10. Depth of the chunks, let's try maybe like 5 for now. I have no idea if this is going to work. Oh, and we need to put our 3D parameters up here as well. So why don't we do that now? Noise density and that are both exposed on spawn. Are you two both exposed on spawn? You are. So if we go to our player controller and go to spawn new chunks within render range, we have access to the 3D noise density. What if I refresh? Was one of them not exposed on spawn? Oh, the cutoff threshold wasn't exposed on spawn. So really what you'd want actually is you'd want a different variable here, which is going to be called 3D noise cutoff below surface. Oops, no, sorry, that's on surface. At surface. And this one here is going to be 3D noise cutoff below surface. And they can both be exposed on spawn. But you don't have to do it like this, you know, like there's a million different ways that you could use this general idea of just 3D noise. I'm just kind of playing around with this now because I'm having fun. You're free to stop this video whenever you'd like. So let me just expose that on spawn. Compile and save. Are they both exposed on spawn? Yeah, they're all exposed on spawn. So now what we have in here is we have our 3D noise density. So we'll call this chunk 3D noise density in the player controller, and put you there. We'll have another one which is going to be chunk 3D noise. Is that even typing? Yeah, 3D noise cutoff below surface. There, and finally chunk 3D noise cutoff at surface. And these are all going to be public, and they should all have defaults because I promoted them to variables from the spawn actor node. Okay, so let me just check that they've all got defaults real quick. Yes, yes, yes. Okay, good. Now, moment of truth. This is when we try and run it and watch the game crash. Called it. Okay, so what if we just reduce things a little bit? Let's change U to 5. The depth, 15 is probably a bit too big. Let's just go to 10. And oh, sorry, I'm in the wrong one. I'm in the wrong blueprint. My bad. Yeah, my bad. So if we go up to the player controller, this is where we need to change the variables. So the render range can be 3, the width can be 5, the depth can be 5. Man, why did that crash? It's not even that big. I guess because it's trying to do too much stuff at once. Like, we need to have it staggered, which maybe I might even do in this video, just so we don't get these crashes when we're trying to start. And now I've spawned inside a block. Cool, man. So let's grab this player start, and let's just drag that up for now, because I can't be bothered doing a system to check where the height is and then spawn us above. And that was perfect. Hot damn. So now what we have is we have a world with a shitty view distance, but nonetheless a world. You can see that the performance when we're here is fine. Like, this is good. But it's just when we approach the edge, we need to stagger them. But anyway, now we have our caves working, so we can jump down here. And they're not very deep at the moment. Oh, can I make it? No, I can't make it. But you can see that they're working. Like, we have caves beneath the surface. Let's try that again and see if I can get in one and show you around. Okay, here we go. That looks like a better one just there. I need to change this gravity scale to be a bit larger. So here you go. Oh, we're falling in and we're falling out the bottom again. Let's just try one more time. One more time. I gotta work on my gamer skills. Gotta stop making games and play games and get better at playing games. Oh, don't lag on me, you fucking... Okay, so now you can see we've got these caves. They're very open. So maybe what we could do is we could just reduce that threshold a little bit. Yeah. Alright, that lag is freaking me out. Let's in the player controller, 3D noise density, 3D cutoff below surface, we're just gonna reduce that. We're gonna reduce the cutoff so we get more caves. Now on the surface it'll look the same because we had a different threshold for the surface. But let's wander into this same hole that we walked into last time. And now we have a few more blocks. They're still not very deep though, because our depth isn't very large. So what if we change that to 10 and probably crash the engine again? Fingers crossed that it doesn't. Oh, this time we spawned in a thing. Oh, I guess because they're building up and not necessarily down. So we're going to need to move that up now because it's deeper. It's kind of like a height, not really a depth. Oh, And spawn on top again. Did I just nail that again? What the flip? Okay. So this is looking pretty good. It's a bit laggy. Very laggy, but it's working. Now can we go down there? No, that looks like it's a dead end. Okay, can we go in this one here? Let's go in this one. Yeah, look at this. Now we're talking. Now we're talking. This is good. Good cave system. Yo, oh shit, I fell really far. Look at this. Yeah, now we got some caves. Okay, so can I jump across there? See, we've hit the bottom already. Like, it goes a little bit deeper, but not much. So what we should do here is we should spawn bedrock. I'm not going to do that today, though. I just want to wrap this tutorial up. But you could spawn a floor at the bottom Z value so that you couldn't fall at the bottom like this. But that's pretty good. That's everything that I wanted to cover today. So I am going to end that video here. And then in the next one, what I'm going to show you how to do is to use a seed so that we can get different generations of that world at the press of a button. So we can set a seed, we could reset a seed, and while the same seed is set, you could restart the level and get the same world again and again and again and again. And then you can reset the seed and you can get a different noise function and a different world generated from it. So we'll set that up. I might also just quickly add here staggered voxel and chunk spawning, because what I might do is I might try and fix that issue where as you approach the edge of the map, the frame rate just drops and it tries to spawn in a whole new ton of things at once. So if we stagger the spawning a little bit, the frame rate shouldn't drop so bad and the performance won't be as terrible. Is that all? I think that might be all. I'm going to leave that there, guys. If you have any questions, drop me a comment. I'll do my best to get back to you and help you out, or if I can't, somebody else on the page or in the community might be able to help you out with your problems. So post all your problems down there, and let me know if you liked this video as well, if this is sort of stuff that you enjoy, or if you have any other ideas of things that you might enjoy that are similar to this that you think I could do. Don't be afraid to leave me a comment, because I'm open for suggestions for new videos. I think that's it, guys. Thank you for watching, and I guess I'll see you in the next one. Peace out.